Hello, this is Mr. Stansbury. I'm going to take you through the 19I notes on stationary points. Okay, at the end of this, you should be able to say I can find and classify stationary points and find the coordinates of those points. All right, so let's talk about stationary points. There's a couple types of minimums and there's a couple types of maximums. There's a global minimum, which is the lowest point on the entire graph. And then there's a local minimum, which is the turning point, which stops going down and then it starts going up. And there can be several local minimums, but there can only be one global minimum. Okay, and then maximum is the same thing except for the highest point on the graph. And then it's a turning point. It's just a local maximum. Just to make life easy, let's just take a look at some examples. So this one here, here is our global minimum. That's the absolute lowest point on the graph at any point. This is a local minimum. It's the lowest point in this little piece of the graph. Those are local maximum. That's the highest point in this piece of the graph. And this is the global maximum, the absolute max on this here. All right. Sometimes the global minimum and the local minimums and maximums can be the same. So this is an example where the global and local minimum are the same, and then there's the global and local maximum are the same. All right. Okay, let's take a look at horizontal inflection. This is not something that you can catch. It's not a disease. It's just more great math stuff. So horizontal inflection is where the tangent to the graph is 0, but it's not a local minimum or maximum. So for example, this is the graph of f of x equals x cubed. It comes through here, and remember it wiggles as it goes through the x-axis. This here is considered to be a horizontal inflection. It doesn't actually stop going up and start going down, but it does have a tangent that's equal to 0 at this point. So horizontal inflection. Okay, that's kind of a very specialized point. Okay, stationary point down here is where f prime of x equals 0. So this occurs at local minimums, like the last graphs we were looking at, the local maximums, and horizontal inflections. Okay, so anytime that the tangent is 0, that would be that. So again, just looking really quick back at this here, the tangent at this local maximum is 0. The tangent at the local minimum is 0 also. All right. Okay, with that, we are going to find and classify all stationary points of this function. All right, so what we want to do here is we're just going to find the derivative of this, so then we can find when the slope of the tangent is equal to 0. All right, so let's see, need to actually get a pen working here. There we go. F prime of x. 3 times 1 is 3x, subtract 1 is squared. 2 times negative 3 is negative 6x, subtract 1 is just x to the first. This is not negative 9x to the first. 1 times negative 9 is negative 9, and then you subtract 1 and that turns into 0. And the derivative of constant just turns into 0. All right, so there is our derivative. Okay, so now again we know that this, since we're looking at this for stationary points, we know that the slope is equal to 0, right? So that's the same as the derivative, so we want to set that equal to 0. It's 3x squared minus 6x plus, minus 9. All right, so nice part about this is we can get a 3 out of everything, so let's divide everything by 3 to simplify. Okay, and we get 0 equals x squared minus 2x minus 3. All right, so we can factor this thing out. Factors of 3 that have a difference of 2 is going to be 3 and 1. They're the only factors. This negative sign goes with the bigger of the two, and then this tells us that these signs have to be opposite. Okay, so x has to equal 3, and also it equals negative 1. All right, so those are the x values. So now that we have the x values, we actually have to find the y values of those points. Okay, so all we need to do on that is just plug 3 into the original function up here and plug -1 into the original function and see what our y values are. All right, so f of 3 is 3 cubed minus 3 times 3 squared minus 9 times 3 plus 5. All right, so that's 27, and then that's 3 squared is 9 times -3 is minus 27. So those get rid of each other. -9 times 3 is -27 plus 5 gives us that f of 3 is -22. Okay, so one of our stationary points is 3 and -22. We'll classify that here when we're all done. So then we also want to find f of -1. -1 cubed minus 3 times -1 squared minus 9 times -1 plus 5. So that gives us -1. That's -1 times -3 is -3 plus 9 plus 5. And that all gives us 10. All right, so the other stationary point that we have is -1 and 10. All right, so since the y value, really probably the easiest way to figure this out, classifying these stationary points, since the y value on this one here is bigger, this is going to have to be a local max, right? And then the y value on this one is the small one, so this is going to be a local minimum. All right. Okay, let's take a short little video break, and away we go. All right. That is a smart and thirsty dog. Okay. Second and last example, pretty similar to this one, but just want to make sure we've got this all down. Find the greatest and least value of x cubed minus 6x squared plus 5 on the interval between -2 and 5. All right, so basically you're looking for a local minimum and local maximum, right? For the greatest and for the least and the greatest. Okay, so again, same idea. Let's do. Oh, that's not what we want. Sorry. Let's do the derivative of this. So f prime of x. Let's see, that's going to be 3x squared. 2 times -6 is -12x to the first, and then that turns into 0. So there's our derivative. We know that since we're looking for the local minimums or maximums or inflection points, that the slope's going to be 0. So 0 equals 3x squared minus 12x. Try to see what we can factor out of both of these, which would be, oops, let's see, we can get a 3 and an x out of both of these, right? So 0 equals 3x times x minus 4. So x has to equal 0 and 4, right? So now that we have the 0 and the 4, we'll just plug the 0 and the 4 in and see what we get. And again, we're just looking for greatest and least value, so that's really just the y. Okay, so f of 0 equals 0 cubed minus 6 times 0 squared plus 5. That turns into 0, that turns into 0, so f of 0 is 5. And then f of 4 is 4 cubed minus 6 times 4 squared plus 5. So let's see, that's 64. 4 squared is, let's see, 16. Let's see, is 16 times -6 gives us -16. would we get 96? And then plus 5, so f of 4 then gives us, if you add that all up, you get negative 27. Okay, so that means, let's see, 5 is the greatest value. And negative 27 is the least value. All right. And again, this worked out because we're supposed to be between negative 2 and 5, and then this fits in between both of those numbers fit in between negative 2 and 5. Okay. Just as a quick side note, you can check all your answers on your graphing calculator by just plugging it in and finding your minimums and your maximums, because that's where your tangent's going to be 0, right? So yeah, you can check all your work on that. So smarter, not harder, right? Okay, you should now be able to say I can find and classify stationary points and find the coordinates of those points. All right, if you have any questions, please ask. Thanks.